Oh, she's sweet but a psycho, a little bit psycho. At night she's screaming, I'm on my mind. Oh, she's hot but a psycho, so left but she's right though. At night she's screaming, I'm on my mind. She'll make you curse, but she a
Hey honey, what are you doing?
I'm watching an experiment about heavy metal water pollution, but I didn't know what the pollution factor that contribute to water pollution.
Oh, let me help you search that up.
1 billion zillion jillion dillion cotillion times later.
Oh, Isu, it looks like there are many possible factors that contribute to the water pollution. But I will give you three examples. First of all is industrial waste. Factories and industrial plants often release harmful chemicals and pollutants directly into rivers, lakes and oceans. These substances can include heavy metal, toxic sludge and other hazardous waste which can severely contaminate water resources. Second of all, there is agricultural runoff. The use of fertilizer, pesticides and herbicides in farming can lead to water pollution when these chemicals wash off fields during rainstorms and enter nearby water bodies. This runoff can cause nutrient pollution, leading to algal blooms that deplete oxygen in water and harm aquatic life. The third one is improper disposal of household waste. Every day, activities such as disposing of household chemicals, pharmaceuticals and plastic products improperly can contribute to water pollution. When these substances can make their way into the water system, they can introduce toxins that are harmful to both the environment and human health. That's all.
Oh, thank you for information, Syed. But how civil engineering can help the reduce impact?
A few moments later.
There are many effective ways for civil engineers to reduce the impact of heavy metal, and one of them is the use of exhaustion techniques with desiccate modular towers, aka LMTs. And the LMTs are designed with liners made from nanoslag, a material synthesized from industrial slag. These liners are blended with clay in different proportions to create an optimal blend for exhaustion heavy metals like arsenic, cadmium, and lead from contaminated water. The contaminated water passes through the LMT and the nano slug liner absorbs the heavy metal, effectively removing them from the water. Studies have shown that this method can achieve removal efficiencies of up to 99% for the certain heavy metals, the elevated temperature and prolonged attenuation absorption rate, making it highly effective solution. Additionally, the aluminosilicate structure of the nanoslag and its high cation exchange capacity contribute to its effectiveness. This solution is promising for mitigating water pollution caused by heavy metal, protecting both human and aquatic health. That's all.
Oh, thank you for information, Syed.
Oh, you're most welcome.
Here we have hot plate, glass funnel, volumetric flask, small funnels, glass pipette, spatula, pipette pump, milk sample, hydrogen peroxide and calcium chloride.
Begin with the sample. Weigh 1.0 gram of milk into a 50 ml aluminium flask. Perform in triplicate. For the sample blank, weigh 1.0 gram of DD water. Instead, do this only once. Inside the fume hood, add 5.0 ml of concentrated nitric acid and 1.0 ml of 30% hydrogen peroxide. To each sample and sample blank, please note that the fumes created by the reaction will be very toxic. Set up the hot plate in the fume hood and heat the flask at medium heat. Swirl occasionally. Your solution should change from cloudy to dark orange brown to clear pale, while your blank should stay clear. If your solution is still orange brown after 20 minutes, add an extra 2.5 ml of nitric acid and 0.5 ml of 30% hydrogen peroxide and continue to heat. It is possible to obtain a clear yellow solution if you put an excess amount of nitric acid, but it does not affect the result. After heating, transfer the samples and blank separately into 100 ml volumetric flask. Rinse each Erlenmeyer flask with DD water and add it to the volumetric flask and make up to the volume. Invert a few times to mix. Next, 1.0 ml of each sample or blank to corresponding 10 ml volumetric flask. Add the appropriate volume of 2.5% platinum oxide solution to each flask to obtain a 0.5% final concentration and make up to the volume with DD water.
Sample and standards will be measured using the atomic absorption spectrophotometer. You must assemble the sample slot, ensuring that it is screwed on tightly, otherwise you will observe leaks when DD water is being fed into the instrument. Turn the control to air while lighting the flame with a lighter. Observe a nice blue flame about 2 inches tall. There is a constant violet blue color. Pay attention if there is any leak around the sample slot. Zero the spectrophotometer by pressing the exact button while feeding DD water. Start with lowest concentration. Dip feeding tube into the standard solution. The flame should turn green. Record the reading and dip the tube back in the DD water. Continue with all standard, sample blank and your sample. Flush the sample slot with DD water. Discard sample, sample blank and standards into containers labeled lanthanum oxide waste.
Report page 1 represents different information about the test and instruments. Report page 2 represents different information about the method and instrument. Report page 3 represents the calibration curve and absorption and results of samples in blank. First of all, we will align some values in the right side of the board. We took 6 mg for sample for testing. That is why weight of sample WS 6 mg. In gram, we can write the sample weight is 0.006. We got the concentration of sodium and sample. We got the concentration of sodium and sample 1 dilution 2 from the AAF analysis, which is 0.238 ppm. We can find the dilution factor of dilution 1 by dividing the total volume of dilution 1 solution by the sample weight. We make 100 milliliters volume and we use 0.006 grams of sample. We can find the dilution factor of dilution 2 by this formula. Dilution factor 1, multiplication sign. We make 100 milliliters volume in second dilution. We made 100 milliliters volume in second dilution. And we transfer 1 milliliter solution from the dilution 1 to make the dilution 2. By solving the equation, we get the dF2 is 1,666,666.67. Now we can find the sodium content in sample by multiplying C sodium, which is 0.2383 by dF, which is 1,666,666.67. By solving the equation, we get the sodium content in sample is 397,166.67 ppm. We can find the percentage value of sodium by simply dividing the ppm value of sodium by 10,000. In conclusion of water pollution, Water pollution is a pervasive environmental crisis, imperils ecosystems and human health. Industrial discharge, agricultural runoff, and improper waste disposal contribute to deteriorating water quality. The impact on aquatic life and biodiversity is alarming, with far-reaching consequences for communities dependent on contaminated water resources. Mitigating water pollution demands stringent regulations, sustainable practice, and public awareness. Collaborative efforts are essential to safeguard these vital resources, ensuring access to clean water for current and future generations, and preserving the delicate balance of aquatic ecosystems.